Hi everyone! Welcome back to our PostgreSQL adventure about databases and pgadmin. Today we're going to have a look at advanced queries like joins, group by and order by. But before we do that, we'll cover the basics of database relationships like one-to-one, one-to-many, and many-to-many. This will help you better understand how to connect data in your tables. Let's get started. Now let's make sure everything is running. So you need to open up your Visual Studio Code inside the folder where you have your YAML file, and you have to have your terminal open. And you also need to make sure that you have Docker running. Okay, so you should see Docker at the top of your screen if you're on a Mac, and if you click on it you should see like a green circle saying it's running. Okay, so in here I'm going to open up pgadmin. Remember, it's on localhost 8080. So I'm going to say first docker compose up, and then I'm going to run it on localhost 8080. So let me go and do that. And I'll put it over right here. Let me make it a bit smaller. And so I've got admin@example.com, admin@example.com, and admin as the passwords. Good. Now, before we write complex queries, let's talk about how data can be related to each other in databases. This will help you understand how joins and other commands work. So there are different database relationships. We have, for example, a one-to-one relationship. A one-to-one relationship is like a passport. Each person has exactly one passport. I mean, let's say Swedish passport, okay? I'm one person, I have one Swedish passport. And the other way around, each passport belongs to one person. Yeah? So this type of relationship is often used when you want to store additional details separately. Let's say we have two tables. Let me show you a drawing. So here's an example, for example. It's a one-to-one relationship. One husband has one wife, and one wife has one husband. Okay, let's try to write this as a query, but then we can use, for example, a user and a user profile. Okay, let's have a look. Okay, so let's open up. We can see we have this cool database, and we have a table in there called users. And now I want one that is called profiles. So I'm going to create another. Oh, and by the way, in the users table, we have an ID and a name and email and a created at stamp. ID, name, email, create at stamp. So let's go to the query tool. And in here, we're going to say create, and then we're going to create a new table. And this one is called profile. Profiles, we could say. And in there, we want an ID, which is a serial, of type serial. And this is going to be our primary key. We are going to have the user ID, so there's another ID, but this is from the user table. Okay, this is going to be an integer, and this needs to be unique. We want a bio, and that's going to be text, and Now we're going to have a foreign key, and that is from the user ID, and it references to the users table the ID. Let's run this. A little error here because I forgot the comma here. So let's check this out. Okay, so let's refresh this one here. Refresh. And let's see what we got. I'm moving myself around. Schemas, tables, and you can see now we have a users and a profiles. And if you look at the profiles table, you can see we have the ID, user ID, and bio. And what we can do here, let's go into the query tool for a second. Select everything from profiles. You can see here that we have the primary key, user ID, and the bio here. So just to explain this part that I had before, where the foreign key is like the link that connects the two tables, the profiles table and the user table together. And it helps to make sure that the data stays organized and correct. The user ID here, that is the column in the current table, so it was from the profiles table. And the references user ID connects the user ID to the ID in the users table. I hope I'm clear. So it makes sure that any value you put in the user ID, this here, comes directly from there. So this must already exist. If we try to add a value that doesn't match any ID in the users table, then the data basically won't let you allow to save it. Now let's insert some data. I'm going to say insert into and the users table first, and I want to add something to the names column, and in there I want it to have my name. Run. Oh, you can see it's not allowing it because it says here that the value in the column email is not allowed to be null. So let me do that too then. Email. And then I'll say Michiel van der Gracht at sunsgarden.se. Run. Great. So I can now let me just select everything from users. Select everything from users, and you can see that it has ID number 4. Yeah. And what I can do now, knowing that it's number 4, is that I can say insert into, and now I want to enter something into the profiles table with the user ID and the bio and the values, and here I need to know this is number 4, and I'm going to say loves coding. I'm going to run this, and now when I say select everything from profiles, I have, this is the first entry, user ID 4 and loves coding. Because this is connected, we can do select users.name, so the name from users table, and from the profiles I want the bio. Then from so this one I'm going to select, and then from users I want to join profiles on users.id equals profiles.user ID. Let's see what happens. Then you can see here. So first of all, I selected users.name and profiles.bio. So name and bio, these two columns. Then I first looked at the users table, and then I wanted to join it with the profiles table on where the user's ID is the same as the ID from the users table is the same as the user ID from the profiles table. So they're both number 4. And there we have number 4 was Michiel, and with number 4 went loves coding. So Michiel loves coding. Okay, so there was a one-to-one relationship where you had a user and a profile and they go together. You can't have a profile that's same to many users. However, there is also a one-to-many relationship, not in this case here, but for example, authors who write multiple books. So one author can write multiple books, many books. But if you look at the other way around, each book has only one author. So it's one to many. You can't have it the other way around. So let's create an authors table and a books table. So we'll do that now. You can say create table authors, and in here we want an ID, which is a serial, and it's the primary key, and a name, the name of the author. We'll do varchar, and we allow it to have 100 characters. And at the same time, I'm going to create another table called books. And in here, we do also a serial, an ID, which is a serial primary key. We have a title of the book, which will be a varchar of maximum 100 characters. We want to connect it to the author, so we say author ID, and this will be an integer, comma, and we're going to have a foreign key where the author ID references, so just like we did before, to the author's ID. So this one here, the author ID, this one here, references to this one. Okay. Now let's run this. And let's refresh. So we have authors and books. Okay, let's insert some data. Insert into, and we do authors, and we want a name, and we have the values, and we'll say J.K. Rowling, and we also have insert into books, and we have the title, author ID, type values. I actually write it on the next line, just it looks a bit neater. There. And in here, we're going to say Harry Potter and we're also going to say let me just clean this up a bit there, and we're also going to say Fantastic Beasts now let's run this there. So you can see 2 books for the same author. Let's delete this. And we do select authors dot name, and we also want the books, and then we want the title from authors join. So from the authors table, we want to join the books table on authors.id equals books.author.id. Now let's run this, and what you can see now is that we get the name, and we get the books, and we get the title, and from the authors table we have joined the books table, where the author's ID is the same as the books.author ID. Okay. Now there's also a many-to-many relationship. So imagine students taking multiple courses, and each course has multiple students. So that's what you call a many-to-many relationship. To model this, we use a junction table. So let's start coding that. And we're going to create the students table we already have. Let's create a table called courses. And in there, we have an ID, which is a serial, and it's the primary key. And we have a title, which is a varchar, and we can say 100 characters there. And we can also now create another table. So we have a students table, we have a course table. Actually, I'll say courses. And now we do another table that has student courses. And in here, I'm going to have the student ID, which is an integer, the course ID, which also is an integer. We have a primary key here, which is student ID, comma, course ID, comma. We have a foreign key, where the student ID references to the student's ID, and we have another foreign key where the course ID references to the course ID. There. So let's run this one. Oh, we made a little mistake here. So let's do this, let's do this, and run. So, oh, I made a mistake. I didn't have students at all. I had users. So I'm actually going to create this table as well. Create table users, which has an ID, which is a serial, and it is the primary key, and a name that is a varchar of 100. Now let's run it. Oh, still another mistake. Primary key. Let's run it. There we go. What? It's not. It should say students. And relation course does not exist. Let's have a look. That is right, because there is no course. It's courses. And now we're good. Okay. Let's refresh. And do we have the so we have students, student courses, okay, and courses. Let's have a look at this primary key here. It is actually called a composite primary key, where we have the student table and the course table. And the composite primary key here use two columns together to make each row unique. If we only use the student ID as the primary key, then a student could only enroll in one course. But with student ID and course ID together here as a composition, it allows the same student to enroll in different courses, and it allows the same course to have different students. So a student can enroll in multiple courses, but the combination of student ID and course ID must always be unique. So you cannot have the same student doing the same course twice, because it would have the same ID for both. That would not be allowed. Okay? So no duplicates, because it's a primary key which should be unique. Great. Now let's insert some data here. And I'm going to do it quickly now. So insert into the students table a name. And I'm going to enter Tom and Sarah. And into the courses table, a title, I have a math course and a science course. Now this is going to be interesting. I'm going to insert into the student courses, and then I have the student ID and the course ID. So he'll have ID 1, she'll have ID 2, ID 1, ID 2. So I can have Tom doing math, I can have Tom doing science, and I can have Sarah doing maths. Let's run this. Here we go. So remember, Tom is doing both math and science, and Sarah is only doing maths. Let's type this out. So we're going to say select, and we're going to do, from the students, we want the name, and from the courses, we want the title. Then we say from students, we want to join student courses on, and then we want students dot ID equals student courses dot student ID. And then we want to also join courses on courses.id equals student courses ID. Let's run this. Oh, I made a mistake. And of course, this does not exist. So courses, and this still does not exist because this does not exist. This is course ID, like so. Now you can see Tom is doing both math and science, and Sarah's only doing the maths. So what happened here? We selected student's name and title, and from the students table we joined the students courses table on where the student's ID is the same as the student courses student ID, and also we joined courses on courses ID equals student underscore courses dot course ID. Well, you can spend some time to think about how this all connects, but this will be your result. So now that we kind of understand the relationships between tables, let's have a look at some more advanced queries. We're just not gonna run them because I haven't fully set up the tables like this. But here's, for example, we can say we have two tables here, a books table and an authors table. The books table has a title column and the authors table has a names column. We're gonna select both of those, and then from the books table we want to join the authors table, and we want to join them on these ones here. So on books.author underscore ID equals author ID. And this here will find all the books and their respective authors. Okay, let's try another one. This code here. We have a books table, and we would have a genre column, which we do not have in this table. But this will look at the genre table, and it will count all of them as book count. And then it will sort them, group them by a genre. So this will count the number of books by genre. Let's try another one. This one here. This one will get books published before 2000 and sorted by year. So from the books table, we would select the title column and the published year column, where the published year is less than 2000, and it would order this by year. You can say descending, or you can say ascending, where it would still count them, sort them, but instead of higher to lower, lower to higher. Great. Okay, so we'll stop here. Well done. We've covered one-to-one, one-to-many, and many-to-many relationships. We practiced using advanced PostgreSQL queries like joins and group by and order by. Now, this will take lots of practice, so keep practicing and don't hesitate to ask questions. And I'll see you in the next lesson. Bye!